19 tabs open up here. All right, welcome to class if you're watching at home. All right, let's look at this. We're connecting two ideas because we've seen this stuff. We've seen it. We've already done a lot of work with functions. Okay, we've done work with functions. We've done work with data. So now we're bringing it together. And this is actually really helpful because the big idea here is, yeah, it's true, Cadence. It's true. The big idea is if data is graphed on a coordinate plane, right, a function can represent the data as a best fit, as a best fit. This is how, if you ended up, trading stocks, this is how you'd be able to see if a stock is increasing in value or decreasing, because you'd be able to look at the data points of the stock value at each point, and you could see a trend that's going up. You could see a trend that's going down. There's all these complicated things, like you see where there's like a bump or a fall, and there's all these different things that stock market people are looking at in order to try to connect the data to a function. And in their case, they're just looking if the function is increasing or decreasing. There's a lot of other aspects to it, but it does just come to that. I mean, they're not psychic. But what we're going to learn at the end is if you fit data to a function, you're going to be able to predict. That's the main thing here. You're going to be able to predict. With the best fit function, you can plug in values of time or different parameters to make a prediction. Okay, that's the key. That's where we're going. That's why this actually is getting into, this is like the edge of a ocean. You're just at the shore right now, but this idea goes so far. Any science field you're interested in, any social science, really anything, psychology, everything, looks at data, looks at trends. Okay, let me know, how's my connection right now? For those I could see in the video, connection's good. All right, it might just be you. All right, might be you, Arn. Okay, hopefully that improves. This is kind of new, but you've seen this before. Scatter plot. If we had these real basic data points here, age and height and feet, 6, 4 feet, 10. When you're 10, you're 5 feet tall. When you're 2, you were 3 feet tall. I think that's kind of tall for a 2-year-old, actually. But you were tall and then you didn't grow much. It's fine. So you're 10 and you're 5 feet tall. Let's see. On a scatter plot is just plotting those points as if it's X and Y. Okay. And remember that if I establish that age is my X, that's why I labeled the X-axis as age. And that makes more sense to label this as age than height, because height going up and down makes more sense. We could see that at younger ages, we were shorter than at greater ages, we were taller. I mean, that makes sense to organize it that way. So when you're deciding what to use for X and Y, just think about it in that way for a second. And in general, the thing that changes, this is more dependent on the age, right? You couldn't be 5 feet tall if you were 2, unless you're like Andre the Giant or some world record holder. So that's not as important. I think that'll become more apparent as we do these. But the new idea here is that a scatter plot just looks at the data points and puts the table onto a graph. Okay? No big deal. Now watch. Our task, because we're going to be given the data, plotting the data points is kind of, just be careful, just do it carefully. But then if I look at the task, right? If I look at the task, our task is to look and see, well, which function is the best fit for the scatter plot above, okay? And that's what you'll be given. You'll be given some data, you'll make a scatter plot. You're going to be given two different functions, and you have to decide which function is the best fit for this data, okay? And it's going to become obvious, ideally we would be able to graph these two graphs on top of this graph, and that's what you'll do. So we're going to graph them down here, though, and maybe I can just put these points here approximately in the same place. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just going to put these in here. It looks like it's like 2, 3, 2, 3, 2, 3. Okay. So it's like tedious, yeah. But if you do any kind of data, analysis for any of your jobs. This is the tedious part. 6, 4, 1, 2, 3, 4, 5, 6, 4. So approximately here. 6, 4, 1, 2, 3, 4, 5, 6, 4. Right here approximately. And then we had 10, 5. So that's maxed out. That's, I know if I did it right, I know it's about there. 10, 5, right? So since I counted up 5 and over 10, knowing that's where those points need to be. See, now I have the scatter plot ready for us to integrate onto these function graphs. Okay. Now you might be like, oh man, functions. Oh man, I forgot how to do functions. Oh, dang it. It's okay. We're going to graph using a table. If you forget how functions work, it's no big deal if we're using with two variable functions here, x and y. We can plug in x values. We can plug in y values. Plug in x values, find our y values, plot those points, and that's going to be our function. So I'm going to do the function in, what's a color that will look good with this? It's all about looking good, guys. Let's see. Give me a color. Green would look good. Thanks, Arnold. Boom. I have every color in the world. All right. Okay, so let's go ahead and graph this. We're going to do it in green. You need me to zoom in a little bit? The key is, all I did was I graphed. You see how these look the same? Approximately. I just transferred it. And honestly, you could have been really approximate with that. It would be fine. All right, one thing we're always going to graph. We're always going to graph 0. We're always going to graph 1. And then I'm going to graph another number that's further out in the mix. Maybe I'm going to graph 10. Okay? So it doesn't matter. I always want you to graph 0 and 1 because those are the easiest numbers to see, what's going on with the graph. And then the third number you can graph is going to be in the mix, right? So I know that at age 10, I'm at 5 feet. So it'd be helpful to know what's going on over here in this side of the graph. So if I plug in 10 for x, it's going to give me the function all the way to that area. Okay, same over here. This is 10. So if I plug in 10 over here as well, then I'm going to be able to figure out what that function looks like over on this side. Okay. I like plugging in 0 because it's the easiest one to deal with. This is where you'll have to do a little bit of work. So y is equal to 1/4 times 0 plus 2. Y is equal to 2. Okay. So we just got to knock them out. And this is actually, I'll tell you, this is most of the work right here, just plugging in. That's why I like to choose x values that are easy to deal with. 1/4 times 1 plus 2. This is going to be 1/4 times 1, that's 1/4, plus 2 is 2.25. And because this is linear, we could plug in 1, we could plug in 100. It's going to be just connecting the dots. It's a straight line. So for linear, it doesn't really matter as much. Sometimes, plugging in random points for an exponential is hard to notice, hard to see what's happening, but we're going to do our best. So now I'm going to plug in 10. Y is equal to 1/4 times 10 plus 2. Y is equal to 1/4 of 10 is 4. 1/4 of 10 is 2.25. Jeez, let me try one more time. 1/4 of 10 is 2.5 plus 2 is 4.5. Third time's a charm. Thank you, Cadence. All right, now let's go ahead and plot these points in green on the same graph. 0 to 1, 2.25. Let's see, 10 and 4.5, which is about here. Oops, right there. And then, if you have a, wow, do I have it handy? Where's my little protractor? No, I don't have that handy. I'm going to use this ruler instead. So you can get a ruler, you can get, really anything. Sometimes those little protractors work well. And I'm going to make my function. And I'm looking at that. I'm saying, man, that looks pretty good. That is a pretty good fit. That is a pretty good fit for my, I know what I'm used. Yeah. I was looking for this. Just a name batch. One sec. Where did it go? Maybe I put it in my wallet. Okay, never mind. All right. So that's already a pretty good fit, right? We could see here that that function fits the points pretty well, right? So I'm guessing that this is actually the function that's the best fit. But now we have to go and check out this one. Okay, so let's check this one out. Let's go ahead and plug in our values. Y is equal to 2 times 1.5 raised to the 0 power. Anything to the 0 power is good, Cadence. Anyone else know what that is? Anything to the 0 power. Good, Arnold. Anyone else? Good, Yancy. Good, Sophia. Close, Sienna. Good, Ahmed. Good, Vivian. Anything to the 0 power is 1. It's that weird rule. Anything to the 0 power is 1, so we end up with 2 because it's 2 times 1. Y is equal to 2 times 1.5 to the first power. Anything to the first power is itself. Okay. And then we have 2 times 1.5, we're going to get 3. All right. Just working through it. This is going to be a big number, actually. 10 might not work for this. It's going to be way up there, but let's do it anyway. Y is equal to 2 times 1.5 raised to the 10th power. Oh my God. I think my calculator's going to break. Let's see. 1.5 raised to the 10th power is, I'm going to go with, it won't matter too much. I'm going to go with 58. 58. So 2 times 58 is 116. Uh-oh. That's okay. I think we're going to be able to see pretty quick that this is not the function that works. All right? So let's go ahead and start to plot these points now. 0, 2, 1, 3, 10, 6, 116. So 0, 2, 1, 3, 10. Oh, man. I'm going to have to put a point way up here. 10. And, 116 is going to be like way up here. But this is what I'm going to do instead. Instead of putting that point up there, I'm just going to note that, yeah, this function goes up quick. You see what I mean? We're just getting an idea of what the function looks like. I know that at 10, it's way the heck up there at 116. Where this one at 10, it was just at 4.5. Okay. So I know that this is definitely not fitting very well. Do you see why this doesn't fit as well? Scroll down a little. I like they said, may you. I may. Is that what you meant? Okay. So we had to figure out which function fit best. And what are we going to go with? Tell me, is it going to be the linear or the exponential? Linear or exponential? Yeah, Yancy. Yeah, Arnold. Yep, Abby. Yeah, Cadence. Yep, Haley. Pretty obvious, though. Pretty obvious. Yeah, it's going to be pretty obvious. Good, Sophia. All right, so now I want you to predict. Because that's the use of this. When you create a function, you can know, right? You can know other pieces of information. So let's just go ahead and say, if they keep growing at the same rate, tell me, predict using the best fit function that we decided on. How tall are they going to be when they're 16? How tall are they going to be when they're 16? How could we figure that out? I want you to put it into the chat when you're done. So when they're 16, how tall are they going to be? Honestly, this is going pretty well. I'm not sure we need to do another example. We'll check in a second here. But tell me, predict. how tall are they going to be when they're 16 years old? And if I'll remind you here, um, I remind you here that we, using the function, when they were 1 year old, they were 2.25. 6? Let me see. Let's see. When they're 16, yeah. Good, Sophia. Good, Rocco. Good, Abby. 6 feet. Good. Yep. Cadence, you got it. Well done. Okay, so if my question was, how tall are they when they're 16? All I need to do is take the function that I know is my best fit, and all I need to do is put in 16 for x, because x values were our age. We put age as our x values. Remember this? As the age. So I'm going to just do this. 1/4 times 16 plus 2. You get 1/4 of 16 is 4 plus 2. So y equals 6 feet. So they're growing pretty quick. When they're 16, they're going to be 6 feet tall. All right. So this applies to everything, that has consistent growth. Now, y, not bad. Okay. So I know, right? So why wouldn't this not work if I said, how old are they going to be when they're 40 years old? Somebody tell me how tall they're going to be in feet when they're 40 years old, and why that doesn't work. How old hypothetically would they be when they're 40? Right? Good, Sophia. How tall would they be if they're 40 years old? And it shows good. Yeah, Arnold. Good cadence. Good, Haley. Yeah, Abby. So you see there's limitations to this. Good, Rocco. Yeah, it's incredible. If I plugged in 40 for the age, we'd end up with 10, 1/4 of 40, plus 2. That would be 12 feet tall. Does that make sense? Does that make sense? It doesn't. It's not logical, though, that someone could be 12 feet tall, right? Unless they grew up on in space. I don't know. With less gravity. I don't know. So, yeah, it does make sense that potentially if they were like a mutant that kept growing, but there's limitations to data. And this is the function that's the best fit, but it has a limitation because it's really only reasonable to a certain height, and then the function isn't as applicable. You just got to keep that in mind. You just got to put in a scenario and just see, does that make sense? It kind of does make sense that at 16, but once you get past 20 years old, then you're not growing too much taller. Some people have a late spurt, but not a lot of people. Yeah. All right, guys, give me a thumbs up, sideways down. I want some good breakdowns of this. I want to see it. Show me in the chat. Thanks. Thanks for the video on for the thumbs up. You can do that at all time. Chat. All right, look at all those emojis. All right. Does anybody, well, let me see here. Tell me in the chat if you'd like to see another example. Tell me in the chat. And you know what? Yeah. Actually, I do feel like that flowed pretty good. So maybe we got it. Maybe I can give you time to work on homework then. Especially if you got a trip coming up, you got some fancy trip. That's awesome. I'm so happy for you. I'm happy for you. I love that island too. All right. Let's go ahead and do that then. It doesn't look like anyone's coming up with needing more help on this. Okay. And we're back to the regular weeks. So this is going to be due next Monday. So we'll have a chance to look over it. We'll have a chance to look over it on Monday as well. But I'm not seeing that we're going to have too many issues with it. Good job. less than 20 minutes for this lesson. All right. Thanks for watching at home. The video, if you're watching the video. not my students at home that are watching live. All right, just to clarify. All right.